A common conversion is converting centimeters into meters. So let's say that you are in the lab and you measure something out to be 7.5 centimeters. And again, you want to convert this to meters because the SI unit for length is meters. So where do you start? You start by writing down what you know. You're given 7.5 centimeters. Then you put the times sign and a line. We want to go from centimeters because I don't want to be in centimeters, and I want to go to meters. Just notice that the centimeters are in the numerator. This is the same as centimeters over 1. I want my answer to be in meters. All right, and the meters have to be in the numerator. So I'm going to get my units to cancel. You can cancel units just like you can cancel algebraic variables. You all know that like x over x cancels out. And just because these aren't all over each other, like the centimeters over here, and these centimeters over here, this is all the numerator, this is the denominator. They can still cancel. Now the next question is, what's the relationship between meters and centimeters? There are 100 centimeters in a meter, or the SI prefix for centi is 10 to the negative 2. And so I can put 10 to the negative 2 meters. That's the same as 1 centimeter. Again, I can either have the letter C. That represents the number 10 to the negative 2. So do you notice that it's either centimeter or 10 to the negative 2 meters? This statement in the numerator, 10 to the negative 2 meters, is the exact same as writing centimeters because centi has the same meaning as 10 to the negative 2. Now, you can cancel your centimeters. Let's change colors, because you have centimeters in the numerator and centimeters in the denominator, and then you can write your answer, and whatever's not crossed out is what's left. And so this equals 7.5 times 10 to the negative 2 meters, or you can leave it like that, or it's 0.075 meters. Again, it's the format that I'm interested in. Not so much whether you can do it in your head. Can you follow this format? Let's try another one. Let's say that you're in the lab and you measure a mass out to be 12.3 grams. And you have to be in kilograms because kilograms is the SI unit for mass. So where do you start? Well, you start by writing down what you know. 12.3 grams. Write down the times line. Whoopsies, that didn't come out right, did it? 12.3 grams times and a line. All right, I want to go from grams to kilograms. So from grams to kilograms. And you know that 1 kilogram is 1,000 grams. How do you know that? Because you've learned your SI prefixes, and you know that the SI prefix kilo is the same as 10 to the negative 3. All right, kilo represents the number 10 to the negative 3. And so I want to point out one more time that notice you can either put the K in front of the grams, or you put the number in front of the grams. So 10 to the 3 grams. That's the same thing as writing kilograms, K or 10 to the 3. Notice that they're not in front of each other. Don't put 10 to the 3 kilograms. That doesn't make any sense. You're either putting the letter in the unit or the number in the unit. So I've got grams and grams, all right, grams here and grams here. And yeah, these are in the numerator. It may not look like it, but right, they're all in the numerator. That's a times sign, so we could continue the line all the way along right here if we wanted to. And grams in the numerator, grams in the denominator. will cancel. So we can cancel that with that, and then we write down what's left, and this is going to be 12.3 divided by 10 to the 3, which is 0.0123, isn't that nice? Kilograms. All right. Now, I think I'll stop here and start another one on the next review.